All right, now that we've got a handle on how to convert volumetrics into engines from the original asset, let's talk a little bit more about surfacing and something that I had mentioned when we first started the video. As you've noticed, we've lost that lovely little preview surface ball or cube or whatever it might have been in your options in previous versions while you're working in the surface editor. So where is it? Is it still there? Yes, it's still there. It's just in a slightly different spot. Under the VPR dropdown, for the viewing modes on any view, you can actually choose a function called Surface Preview. Surface Preview has an additional set of options that are found under the VPR gear tag, the upper right hand side of the corner of the interface. And it has a couple of different functions here that will allow you to preview whichever object you want with preset light, selected light, whatever it might be. In this case, I have key selected down here at the bottom. All the scene lights. You can choose a preset object, the scene object, or a selected object. Right now I don't have one selected, so it doesn't know what it's doing. There's the head. Even though it's the head that I have selected, it's going to display the whole thing. Preset. You can use cone, cube, cylinder, sphere, torus. So remember that, if you hit D, you can bring back the viewports and have a surface preview window open while working with any of the other layout types that you want. So you want, perspective view over here. And you want to have this one running with VPR as well. You can. So any of the changes that you make to the surface, shift clicking for that surface. It'll select it in the surface editor. You can bring up the node graph for that surface and start editing away. Any changes that you make, of course, to it being reflected in any of the views that you might have surface preview available for. So while this layout might not be optimal for doing that, maybe you want to have something that's ranged a little bit more like so. And we'll go back to the menu options for the viewport. Something, say, 2 left, 1 right. So let's want to surface preview and just leave this one as, say, wireframe or even shaded text or solid. This one could be VPR. That way you've got something that's the surface preview with the surface editor kind of covering up that other interface. If you're working off of a single monitor, this might be ideal for you. But it gives you the ability to shift click anything that you need to for the surface and then get the surface preview window up here if you want. So that's a fantastic way to go about it. Now, I had done some experimentation here in updating the surfaces for this Raider, and I want to talk about how you can quickly go from, say, the standard material, which is what all of this stuff is right now, with the exception of those 2 top wing bits. There's one for conductor, and then there's one for principal BSDF. You can see the differences between them reflected in both the surface preview and the menu itself. So you can convert basically all of these surfaces over in one go if you want to a principal BSDF set of nodes that will allow you to edit them. Or you can convert them to standard nodes, which will give you all of the original texture editor types, but in a nodal sense. So let's, for example, click on the head here, and I'm going to just open up this node, and you can see there's really not much in here because it's basically buried in its own set of interface, but you can have this up while editing, or it's really just a copy of this over here. And if you want to get better access to it, right click it and convert to standard nodes. What this will do is actually break out those textures that we had with the T buttons into their individual components and then allow you to feed them directly into the ports of the standard shader, which then goes into the surface. This can be quite handy actually, because now you can start mixing and matching different items and different properties. But if you also want to try out something like a different type of node for material, let's say we want conductor material, and we want to start plugging stuff into this and then switch back and forth by just rewiring it, you can. Now, you'll notice here on the actual surface, there's a slot for OpenGL. If we go back to the OpenGL view, you'll notice that a lot of the surfaces are not textured very nicely. You can actually get a really close approximation of what's represented in a surface, but it has to be done through something, say the standard node. And we can make a copy of this really quickly, and I'm just going to show you what I mean by this. Instead of plugging the material here in, because we have elements that are like this particular texture, that particular texture, basically the last one is going to show up. So let's take the Raider head top, hit color, copy current layer, thank you very much. And we'll go and create a copy of this, plug it in here, turn off that layer, which we don't need it. Just plug it into color, and we can run this material to the OpenGL input on the surface. And now we will see in OpenGL that texture applied. This can be quite handy for taking a look at things in OpenGL shaded wire for what they are with the actual surfaces. And this model, because it doesn't have UVs on it, however, if it did, would be very easily transportable over to Octane and to Unreal, just using these nodes and then being able to plug them into the Unreal outputs. So fantastic way to just give yourself a quick viewer. And keep in mind that Lightwave, with its OpenGL functionality being enhanced in 2018 and above, if you go over to, say, the GPU settings, a lot of this stuff will actually show up. It just comes down to whether or not your GPU is capable of displaying it in OpenGL and how deep those layers go. So you'll get things like bump map displayed, transparency displayed, but it's going to be limited to just how many layers in the texture it is. And we are no longer limited to 8GL lights now. You can type this up to basically a very large value. I think the current is 64 or 128. It might up be up to 256, but this was a limitation of GPUs for a very long time. Depending on if you have a GPU that's more modern, you can take advantage of, say, 16 lights, and you don't have to be worried about trying to light something in VPR. If it's a really heavy scene, you can try to light it in OpenGL, and you should get very accurate lighting results. For example, we've got about 8 or 9 lights in here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. If we had more, we would be able to see them interact very easily. So we wouldn't have to be always lighting with VPR open, which can sometimes be tasking on the machine when you got a really, really heavy scene. Let's very quickly talk about a little bit of workflow for texturing some of these things if you want to convert stuff over. Like I said, you can bulk right click, just shift right click and convert to either standard or principled nodes very easily. But what I like to do is convert to, say, this head. We've already converted it to standard nodes. So let's go shift click for VPR. So there's the top head. Let's double click that for the node tree. Okay, so I've got something in there that we can work with. Let's say I want to kind of maintain this kind of flow, but I want to have this kind of plugged into something that's a physically based surface type. So now that I've got the standard one exposed, let's right click and convert to principled nodes and watch what happens in the background to the layout of the node editor. So now we've got a stack of those exposed nodes from the original standard material, and now a principled BSDF material in there, which has rewired itself to the surface. Now, because there's no direct translation between these types of surfaces, we would have to do a little bit of work. And I've kind of screwed myself up a little bit because of the location of where I did this at the time for the nodes to be created. But it's really straightforward to grab the ones that are relevant, move them off to the side, further each type of grouping. Running I can mouse properly today. There we go. And then use these as a base to start wiring things up for the principled node. Okay, so let's take a gander at this. I'm going to go back to my large interface, and we're going to go back to VPR. Okay, good stuff. So it's been converted to principled BSDF. I don't necessarily like the look of this just by default. I would prefer something a little bit more along these lines. And that means either tweaking it with these nodes to try to match it, or going with the conductor node, which is what this wing is using, which is actually a simpler type of material to bring these surfaces in compliance with the way that I think it should look, and going through them and turning certain layers off that really should have been turned off because they're being driven by other properties in the surface. So that's a little bit more involved than what these videos are for. You can certainly start with a principled BSDF node type and plug things in to the different slots on a principled BSDF material. Working with the original textures that came in across the original asset. As so. Or once you've got a material converted, depending on how the textures originally were produced, a simple solution here. Let's get rid of this stuff just for the moment. That off to the side. Don't need that. Don't need that. Wire that to our bump over here. And we'll take the original standard stuff, put it off to the side, right click it, and we can turn it into collapse. And we can also turn it into a compound node or tidy them up so that they look prettier and they're kind of out of the way. But getting back to what I was saying here, we can now take some of these functions, like these various layers, and I don't think we need these color ones. We'll use this one here instead. I'll go into color. Specifically, the diffuse, scalar, and specular can be recycled depending, again, on how they were created in the first place, with a couple of simple tools be used to give this a little bit more life. Like, we don't have a lot of specular hit off of this or anything like that. So the reason being is that there's nothing in there. It's basically got 0 for specularity on it. So if we pop that up to 50, you'd start to see some specularity kicking in, combined in with the bump map. Roughness is at 10. Turn the roughness down, it'll start popping things out a little bit more. But really, we need a texture to derive this. So let's override these values with actual texture information. So let's take specular, for example, and plug it into roughness. That might help us out a little bit, but I think in order for that to work, we're going to need something called invert, which is an invert node, and this is quite common to use in these types of scenarios, especially when you're working with surface sets that are coming into Lightwave from a physically based renderer, but the textures were set up for a different formula: roughness, specular, metallic, those types of properties. So you can use the invert tool to invert some of these layers. Might help it out. I found that in particular with this asset, it was a better idea for me to use conductor because it looks just so much better. But I'm not going to go through the process of setting this up right now. However, I am going to show you um, that you can load any of your presets that you might have had, because I did save this other wing out as a preset. So right click, load my preset, or load surface. So there's top right, boom, wham, come in, and now I've got the two tops of the wings matching. So it looks a heck of a lot better. So in this particular case, I'm going to go through the entire model with conductor, but I don't want you guys getting bored watching me do that. That'll be a conversion process that I'll do off to the side. But it does look really lovely once it's loaded. It really does play well with the lights. A couple of things about lights before we go. This normalization function effectively takes the highest and lowest value of the luminosity being created by light and jams it into a compacted space between 0 and 1, and gives you a more concentrated light look. If you turn normalize off, you're going to find that the light intensity, which is in lux, will have to be increased significantly by very, very large orders of magnitude, like 1500% or 1500 lux, before it'll actually start to impact surfaces. So using normalizing on lights, if you're working with very minimal ranges that are like sensible, is the way to go. Otherwise, if you have for a special case purpose, you're going to want to work with normalize off, and probably working with nodes with the light information to control things such as fall off, intensity, that sort of thing. In particular, if you're going to be recombining volumetric effects with this. But for the most part, distant lights, we'll just change this up a little bit. Area lights, skip the DP light kits there. Environment will not have one for normalizing. Linear, and gone. Photometric will not. Primitive, just an object shaped light. spherical, which is kind of like a point light, but it actually has a dimension to it. So think of a ball that is a spherical light. And of course, the sunlight light won't. The rest will. So the common lights that you're familiar with from older versions of Lightwave will have that normalized function. Portal is something that's a little bit different. That's for lighting interiors with HDRI, working with the environment light. I do have a video for that out on the Lightwave 3D YouTube channel already, so make sure you take a look at how that works. All right, so let's just go back to key light here, and let's make sure that that's changed back to a distant light, because one of the things that you may not realize, and this was something that was in 2015, but we would use dome lights for this. You'll see that the dome light has been removed from 2020 or from 2018 upwards. It's because in the distant light, we have the ability to use an angle input. And if you were to visualize the representation of this, it would just become a dome light, very similar to how it would display in Lightwave from previous versions. Camera view for a second here. Samples. Light samples are effectively an individual input for each type of light that you've got. You'll notice now that you do not have in the general or render tab a function of having lights have their own sample set as a global control. It's now individual, and you also have individual samples for volumetrics. You can dial in the volumetric samples and the sampling for distant light or any of the other lights so that you can increase the quality of shadows and also the quality of the light that is reflected back from the surface. Volumetric samples, the defaults, and I got to recommend this to you, working everything in powers of 2. So like if you're starting with 1, okay, the next one is 2, 2, 4, 6, 8, 16, etc., 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 etc. You don't want to do silly numbers like 7 or something like that, thinking that's going to help you, even though it might be slightly, between the two qualities. It's always better for a computer to work in multiples of 2, and that's why we use 2 as a base. And if you want, you go up to 4, 8, 16, so on, so on. Same thing goes with any of the other properties for reflection samples, refraction samples, subsurface scattering, etc. This also translates into camera properties. This, because we imported this scene into Lightwave 2024 from a previous version of Lightwave, where that unified sampling system was just still maturing, and this was an old asset from before unified sampling was even introduced. It's saying minimum samples and maximum samples 1 and 9. Reality is that if you're going to do motion blur in the new motion blur rendering system, you need to have minimum samples of 2, and you can go maximum samples of 4, and you would get a comparable anti-aliasing quality that you would have gotten out of the previous version of Lightwave. It doesn't need to be that high anymore because it's doing a lot more refinement and better work of doing so than the original camera system that was in the product. I like to split my minimum and max samples if I have motion blur enabled. So if I need to go a little bit higher for just quality, then I'm going to be at 16 for maximum samples and 8 for motion blur. Although that's not always the case, but if I'm going to find that the product is looking in a certain way and it's really, really nice quality, we go 8 or 8, but you can generally get away with half of the minimum, and that half will give you the nice edges for motion blur and other factors. Motion blur has also had some changes to it. You'll now see that we've got subframes and shutter open, shutter efficiency, rolling shutter. There's a great description for this in the manual. If you are looking though for an indicator of what this would have been in terms of degrees of offset of the shutter, the roll off roughly 35% in either positive or negative direction would have given you 270. 50 is an approximation of 180. Some people think that they can get away with lesser frames for motion blur. You certainly can try that. It's been done. We can, you know, do tests of that and see the best results. But the default when you open up a scene, because this is important and only paid attention to these parameters on the original camera, this is going to come in with Lightwave's default settings. So be careful and know that this is something that you might need to adjust. But you will get the shutter angle indicator down here plus the exposure time. So it is telling you exactly what you're doing based off of blur length. So there's shutter angle, exposure time, etc. Stereo functions haven't changed. There are improvements to this if you have just recently joined Lightwave and you're in older versions such as 11.6 where they made kind of a bigger deal about stereo stuff. There are certainly improvements to this area. I highly encourage you to look at the manual for this and how to take advantage of it. And this is something that can be used in combination with the VR camera, which is now an option type. We also have access to shift camera, real lens camera, perspective camera, orthographic camera, surface baking camera, U3 VR, and just VR camera. Make sure you read up on all of these. What you're going to be missing though is the classic camera that has been dropped completely in later versions of Lightwave, and it does impact the look of something like particles in our tracer fire that we had on Galactica. But you know what? That actually was impacted in Lightwave 11. That's where things stopped working properly for that because, or actually in Lightwave 9.0 with the introduction of the perspective camera. It wasn't anything else but the advancement of the perspective camera technology being included because it wasn't reading the ramping of the particle being increased over size and stretch. This is something that I brought up with the development team for Lightwave Digital and see if we can get that kind of look back in some way. We'll see what happens in the future, but it might not be done necessarily through this type of particle arrangement that we had in the original. It might be done through something else. Let's briefly touch on depth of field. Same capabilities as you had prior. Of course, with VPR, you have a better, faster evaluation of this. If you want, again, a better look to this depth of field, increase your filter radius and up your maximum samples and it'll refine it. Now, when you see me mousing around the window here quite a bit, VPR in 2018 going up to, modern 2024 and beyond had the implementation of a situation where if you want to focus a render quality or improvement on a render faster than just the regular image like it did before, you just mouse over that area and it'll continuously recycle and refine in that moused area every time you move until it finishes, and then it'll start to circle and spiral out. So let's crank this right up. Let's go 128 by 256, and I'll mouse over it and you can see that it returns the concentration of CPU power on that area until I don't touch the mouse, and then it'll start refining the rest of the image. Let's go back to something reasonable. Yeah. Very clean, renders quick. Now that's VPR. There are very, very few limitations to VPR. It is effectively the production renderer now. There's only certain cases where that might be not the situation where you will have a VPR render looking at something and it will have a mismatch to the actual F9 render, and that's very, very rare. But you'll see that the production render F9, same thing again. This will render to total final, but this render might appear to be slightly slower than normal, but it It's usually because you've got something else additionally on top that's being evaluated. For example, in this case, I had Star Pro in the background. Obviously, this default that I had isn't working for us. Those are really big fat stars, but that pixel processing after post and a few other factors may cause it to be a little bit slower. But if you look at VPR's render duration, it was actually slower in VPR than it was in the F9, which is the full production render. And we had an addition of it walking through Star Pro, generated that, and then of course Flare to Alpha. So very interesting that you can get a faster render out of a production F9 than what you can get out of VPR. It really depends on what's going on. There are a number of factors that can influence that. But this asset used to take several minutes on the machines 20 years ago to render, and that would only be one pass. Now we're talking about getting a beautiful, lovely pass with these environment lights and all the other lights that would be considered into it with a physically based material. Granted, my Star Pro stars kind of suck here. Uh, we're getting that much more quality and that much more capability out of the renderer than we ever were before, and our machines are faster, so we're able to output higher quality images than we were previously. And we're working with the modern surfaces mixed in with the old standard emulator. So this is running slower than it should be because the standard shader is an emulation of the original rendering and texturing solution from versions prior to 2018. And as a result, when you mix and match these in a single scene, when we're doing ray tracing, say there was a piece of glass in here or something, and there was something be reflected into it, it would have to evaluate that. It would slow it down. So it's better to go either all physically based or all standard, or if you need like standard, keep it very minimal to just a handful of surfaces, and you'll get that speed benefit. But you can see that we can get a really, really lovely looking image out of this very fast. Granted, the surface on the rest of the ship isn't all that great. So why don't we do something about that really quickly, and we'll just see what we get. Let's just convert it all. Convert. Let's turn VPR to do that. Well, that kind of blows. Oh, wait a minute. Yeah, I converted them. It is a standard node now. Fair enough. Let's go. Convert to principled. Sorry, operator error. Now we can bulk do that. The rest of them. Convert to principled. For example, a good reason why this material would want to stay standard is that eye. It's doing something very special in our scene. And there will be use cases like that where you're just going to want to stick with standard materials on the occasion. So we got two more here. For standard material. For principal material. Right, back to VPR. Boom, boom. So that's now all physically based material. Let's see what it does for render time. Pretty much the same thing. So don't let anybody tell you that the render engine for Lightwave 2024 or 2018 is slower than what it was in 2015. It's totally a different animal. Okay, one was a biased renderer, which was the original, that was using a very peculiar method for doing lighting shading, and in some ways it has its advantages. And then there's the 2018 going up to 24.4 and beyond, physically based rendering solution that is vastly superior in terms of the capabilities it has, and you're looking at materials that can do stuff that we would never be able to have done in the previous render engines. So it really just takes an understanding of this new surface system, knowing when and where to use it and how to use it, feeding it proper textures for the various formulas or texture theories that are out there, being roughness, metallic, glossy, specular. So those are all physically based material systems, and plugging them in. And I guarantee you that the nodal input for doing something like this will be a heck of a lot simpler if we'd already started with one of those theoried systems. If you remember, we were looking at the surface of this and taking a look at conductor. There aren't really a lot of inputs here in comparison to, say, the standard material or the BSDF one. And if we already had a texture set that made sense for that type of material, we'd find that a lot of this would be reduced greatly. We wouldn't need to go into a huge, large amount of texture layers. The scalar layer would be quite simple, because we'd be probably building an asset like this today with UVs, but there was a very good reason why an asset like this was built largely without, and it came down to ultimately producing a high resolution version of this, working with projections so that we could decimate it by reducing its polygon count, or destroy it by breaking it up with the tools that we had in Modeler at the time, rather than fracture, which we have now. And the UVs would not be a concern because they would get destroyed, and we'd be able to swap models out very, very easily. We could even swap them out in the middle of an animation, and you wouldn't be able to really tell the difference, and it would work just fine. So, in closing, this is just a tip of the iceberg for the moment, but there isn't a huge amount of stuff left that you should be concerned about going from 2015 to 2024. That's going to be a big gotcha right off the bat. The rest of this is going to be things like there's new features, there's new functions. You can do this now. This is, kind of how we do things for things like displacements, surface displacements, those types of functions that will just improve your work and allow you to output higher quality than you were able to in previous versions. And that's stuff that we're already covering, and we'll have more videos in this series, obviously, because some of those areas are a little bit different, but the premises are all the same. It's just a question of workflow and understanding that the developers have come up with some fantastic ways of enhancing what we did before and making it better, rather than just completely blowing something away and coming up with something new and going, oh, well, here. It's like going from 3D Studio to 3D Studio Max way back when. That was a nightmare. Or from XSI to, or from Softimage to XSI. You don't have to throw the baby out with the bathwater with Lightwave when you upgrade and you're working with the product. If you haven't worked with it in a while, this is all going to still feel very, very similar and very familiar to you. And what is different has been changed for the betterment of your work so that you can make it a higher quality and in a faster, more competitive environment. All right. Thank you very much for watching. We'll be back in another video.